All right, so let's talk about what the inverse sine function is. So we already talked about, if I have an inverse sine, let's say of 1/2, right? That's going to be basically thinking about our unit circle and going back to which angle has a sine value of 1/2. So you could think about your terminal points on the unit circle and say, well, the y value is 1/2 right there at 30. But also, at 150, the y value is 1/2. So the sine of both of those angles are 1/2. And this is what we talked about in the last video of, okay, there's multiple angles here where the sine is 1/2. And so we come across this little bit of a dilemma here as, okay, well, which one do I write as my answer? What is the answer for this? So let's go back and talk about what the inverse sine function is and define it. So the inverse sine function, we can just write like this, that the y, or y equals sine inverse, we'll write it like that, of some x value, right? That is a function if and only if and only if this equation is also true. That means that the y value on the unit circle, right, is equal to the sine of that angle, right? So we say y equals sine inverse of x. That's the sine inverse function. If and only if x equals sine y. What does that mean? So if I wrote it like this down here again, that would just be saying something like the sine inverse of 1/2 is equal to some y value, right? Well, that y value would have to be something like this. 1/2 would equal the sine of this y right here. Right, that angle, we're trying to find the angle that makes this true. So the sine of 30 degrees is 1/2. The sine of 150 degrees is 1/2. Right, but which one do we choose? So the one that we choose, we're going to have to come up with some rules to make sure that we have one answer. Let's look at Desmos to kind of see how we're gonna make these rules. So if you look at, there's the sine function, and as you can see, it passes the vertical line test, right? So that means that each input has exactly one output, and this is clearly a function. If you were to switch the x's and y's and put x equals sine y, this is really the inverse relation right here. And you can see in purple, this is not a function, right? Because it doesn't pass the vertical line test. So if I were to say something like, where is the sine of which angles are 1/2, I could do something like this. Man, there's a lot of places where the angles have a sine value of 1/2. Right here, pi over 6, 30 degrees that we already just said. 5 pi over 6, 150. And 13 pi over 6, and negative 7 pi over 6. And if I zoom out, then I would get an unlimited or infinite number of intersection points here. So clearly, too many answers. So how do we make this a function? Well, all we're going to do is basically take this function, and we're going to restrict its range here. We're going to restrict the domain of the first one, and we're basically going to say, imagine that we take like scissors here, we just cut a little bit of this purple function or purple graph so that it is a function and it does pass the vertical line test. So this is how we define it for the inverse sine function. So we basically go in there and we say, okay, all these angles are true that equal 1/2, right? But we're just going to actually think of this function as going from, or the range as being restricted to negative pi over 2 to positive pi over 2. Right? So we're just taking this little bit out, right? Now, if I said, look at this graph, does this pass the vertical line test? You'd say, absolutely. There's just one intersection there at 30 degrees or pi over 6, right? So this is part of the definition of the sine inverse right here, this extra bit of information, because it cuts down it cuts down the range of this graph so that we only are outputting one answer and not an infinite number of answers. If I took that out, well, then I have an infinite number of answers. If I put it back in, then I just have one. So this just happens to be part of the definition of the sine inverse function. Keyword there is function. We have one input and one output. So we say here, back to our definition, we say that the range, the y values right here, have to be restricted. So we say that the y is going to be less than or equal to negative pi over 2 or negative 90, and less than or equal to, y is going to be less than or equal to positive pi over 2. Okay, if we wrote that with degrees, that would be like saying negative 90, y is going to be greater than or equal to negative 90, and less than or equal to positive 90. So this is part of the definition of inverse sine here that we have to make note of, right? Is that the range of this inverse sine is always going to be between negative 90 and positive 90, right? We sort of have to cut that function so that there's only, or cut that graph like we showed here, so that there's only one answer, right? So that, you know, your calculator will know it has these rules programmed in, and it's only going to give you one of those answers. So back to our question here, right? What is the sine inverse of 1/2? Well, we have multiple spots on the unit circle, right, that give 1/2. We have one right here, we have one right here. However, because the range is defined as negative 90 to positive 90, I'm only going to take any of the answers that are from negative 90 to positive 90, which you can see here is going to include the 30 degrees. It will not include the 150 degrees in this problem. So my answer here is going to be 30 degrees. All right, so let's try some of these problems. So let's say, what is the inverse sine of root 2 over 2? So we're trying to figure out, you know, which angle is that true for? So if we think about our unit circle, and we have our unit circle, what we're trying to do is figure out where is, on the unit circle, where is the y value root 2 over 2? Where is the sine value root 2 over 2? Well, that's going to happen positive, so right here up at 45, and then another one at 135. So here is 45 degrees, 135 degrees, because if you think about those terminal points, it's root 2 over 2 and root 2 over 2, right? And negative root 2 over 2 and positive root 2 over 2. So my sine values are root 2 over 2 in those two places, right? Well, which is my answer going to be? I have to go back to the definition of the arc sine or the inverse sine, which is only going to take answers from negative 90 to positive 90. So I have to remember, oh, but I'm only going to take values from negative 90 to positive 90 in that range, so therefore the correct answer here is going to be 45 degrees, or pi over 4. All right, let's try another. Let's say we have the arc sine of negative 1. Now, by the way, arc sine is the same exact, it's the same way of saying sine inverse. It's just another way that we can write this out. So this right here, arc sine, is the same thing as saying sine inverse of negative 1. We're still trying to figure out which angle there is going to work. So think about, again, my unit circle. And I think about, where is the y value negative 1? Right? So think about my unit circle. Where is the y value negative 1 on the unit circle? That's going to be down here, right? Because the point That is the only place where this point here is going to be 0, -1. But what's the angle there, right? It's the same position, but we could say, you know, this is 270 degrees, right? We could also say it's -90, right? And we could also add 360 to all these and subtract 360. We need to make sure that we report the angle that's in between -90 and +90, because that's the definition of inverse sine. So we know the location is right here. However, the answer to this, we're going to find the angle that's in that range. Find the coterminal angle that's in that range, which is going to be -90 in this case. So we'd say -90 or -π/2. There's my answer, because that's the angle that fits in that definition of what arc sine is, or sine inverse. Try one more. So let's say we have sine inverse of -√3/2. I take my unit circle out, and I think about where is the sine, -√3/2. Well, that's going to be down in quadrant 3 and 4. So here or here. Let's do radians this time. So this would be like saying, this angle would be like 4π/3. This would be like 5π/3. Those two places, right, would have a sine value of -√3/2. Well, which one is it? Again, we have to go back and say, well, I'm only going to take values from -90 to +90, or in this case, with radians, it's going to be, so -90 to +90. With radians, it's -π/2 to +π/2. So then you say, okay, well, it's not going to be this one. I can't take 4π/3. 5π/3 seems like the right one, but that's not actually inside that range. It's too much, right? That's a case where you're going to have to, you know, find a coterminal angle there and say, well, 5π/3 is the same thing as just -π/3. This is the same thing as -π/3. That's going to be my correct answer, right? If you're doing this numerically and you're just saying, well, I got 5π/3, you know, that's the correct location, well, then you could certainly just add or subtract 2π to that angle, coterminal angles, until you get within the agreed upon range there. So if you were doing this like step by step, you could say, well, let me, you know, 5π/3 is too much. Let me subtract 2π, or 6/3 pi. I subtract 2π from that, and then I get -π/3, and then I look up in my rules and say, ah, yes, that is within the agreed upon range, and that's coterminal. Therefore, the answer is -π/3 in this case. Now, you should be able to do these without a calculator, okay? But note that you can certainly check your answers as you're going through this with a calculator, because the calculator will give you the correct answers when it comes to these functions. So I could simply type this in and say inverse sine, you have the second sine of -√3/2 over 2, and it's going to give me the correct angle there, which that's in radians right now. That is equivalent to -π/3 right there. If I switch my mode to degrees, and do the same thing, it's going to give me -60 degrees, right? So that you can certainly check your answers there. The calculator will, of course, understand those rules with inverse sine, but make sure you can do this without a calculator and just using your unit circle skills and being able to think through that process and understand what the inverse is and what the output has to be.